Welcome back to part 2 of our Bandit walkthrough. This time we're going to get through levels 5, and I think we're going to get all the way to 10. So let's just dive right in and start with level 5 here. So let's paste in our password. Okay, so for this level, the password for the next level is stored somewhere in the in here directory and is human readable, 1033 bytes, and is not executable. So let's take a look first, just what is in our in here directory. In here. Okay, so we can see a bunch of subdirectories called maybe here, and about 20 of them. So we don't want to look through each of those one by one. So I think in this case we're going to take a look at the find command. So if we just run find from within this in here directory, we're going to get a listing of every file that's within any of those subfolders. So let's just run that real quick, and we can see that there's quite a few options, quite a few files I should say, within here, and we don't want to parse these one by one just to figure out which ones are the correct size. There are options within find to figure out or to filter based on file size. Let's go to our friend Google, and we will do find based on file size Linux. Okay, so it looks like our first option is how to find command to search for files based on file size. We can see from this example that they are trying to find files that are 6 megabytes in size, and we want bytes. So fortunately it gives us this, it tells us that C is the option for choosing bytes, and we know how many bytes we're looking for. So let's run our find command again, and this time we'll do size 1033C. And from there we see that there's only one option, which is the file2 option. Let's cap this file here. Maybe here 07 / hidden file 2. And sure enough, there's our password for the next level. Let's copy this, and I just want to go back real quick, and if we want to look at files that are human readable, I'm not quite sure exactly what that means in this context. I think it probably just means a text file. Or if you want to look at files that are not executable, there are other flag options within that find command to get rid of files that are non-executables, or I should say to filter out based on either of those properties. So I know one is using the type command will get you the specific file type, and I think there's an executable command that you just might have to figure out a way to get that to not show executable files, or to show not executable files, I should say. Let's get out of here, and we can move on to our next challenge. All right, Bandit 6. Not correct. Did I not copy that properly? Let's try again. There we go. Okay. For this challenge, the password is stored somewhere on the server and has the following property. Owned by user Bandit 7, owned by group Bandit 6, and is 33 bytes in size. I'm going to guess from this there's not going to be any files here, and that's correct. What we can do is traverse up a couple directories just so we can get a better understanding of what's going on here. So right now we're in the Bandit 6 user home folder. So if we go up one directory level, we'll be able to see all the users' home folders. So you can see, other Bandit users. This is obviously a server that has a lot of users. Let's move up one more. And from there we can view the entire file system. This is where we're going to run our find command from. We can also, and I'll show you after this is over, how we can just run a find command to specify this. Let's start just by looking for a file that's, again, like last time, of size 33C. That's 33 bytes, and we see that there are a lot of files that come back that are 33 bytes. We see these permission denied errors. In those cases, these are files that we don't have access to, as as our current user. One thing we can do is let's filter this down a little bit more so that we can only get the files that we're looking for. So let's find files that are owned by the user Bandit7 and by the group Bandit6. To do that, we just do user Bandit7 and our group is Bandit6. Again, we get fewer files this time. We still see this permission denied error though, and that's the case for quite a few files. We want to do our best to get rid of that. So I know that this particular, the find command is returning a permission denied error, which is considered standard error output, whereas a file or output like this is just standard output. To get rid of that error output, we can pipe that to dev null. So to do that, we want to take group 2 from this, and we want to send it to /dev/null. And from there, we only get our one file that is the result of that find command. So let's copy this, and let's go cat that file and see if it is indeed what we're looking for. And we can see that it is. To run, let's copy this, and if we want to run this file or run this command from anywhere, we can go back to our find command and just specify that we are looking for files that are in this, that are in the root directory. So if we run this, we should get the same result. That's how you would run it if you were already at the root directory, but if you weren't there, that's how you could do it. All right, let's move on to our next challenge, Bandit7. Alright, so this password is stored in data.txt next to the word millionth. Let's cat this file and see what we can see. Okay. We're not going to be parsing this one by hand, obviously. We can see quite a few files in this, or a lot of strings in this file. What we're looking for is something next to the word millionth. For this, we want to use this grep command. Two different ways to take a look at this. The first is to just use the grep command as it's kind of intended, which is doing grep, and we do the string that we're looking for, which in this case is millionth. We don't need any special characters like quotes if we're just doing a string like this, but grep is very powerful, and you can use things like regular expressions and things like that. But for this, in this case, we don't need anything like that, and we'll specify our data.txt file at the end. We can see that this millionth file is here, or the millionth line is there, and this is our password for the next level. So let's copy that. I do want to show you another way of piping things into grep, or putting data into grep, which is through the pipe. We can do cat data.txt, and we can just pipe that. All those strings will, the entire output of that line will go into grep, and we can do millionth from here, and that will give us the exact same result. Two different ways to take a look at that, or to think about that problem. I tend to think about things by catting them first and then figuring out what command I want to pipe them into next. But either way will work in this case. All right, so let's copy this and move on to level 8. Okay, so in this case, the password is stored in data.txt and is the only line that occurs once. Let's cat our data file, and we can see a lot of lines, and it sounds like some of them are, all of them except one are repeating. In this case, we want to use both sort and unique to find what those lines are. So sort and unique are a couple of Linux commands that really are great in conjunction with each other, and I'm going to show you how to use both of them right now. Let's cat this data file, and the first thing that we're going to use is the sort command. So let's just see what that looks like with the output. So sort does what it says on the tin, and it just sorts all those lines by the first character, and it will group them. Obviously, you can see that there are a lot of repeating lines, and what we could do is look through this entire list and try to find the one that is only in there once, but unique will do that for us. If we go to our previous command, just hit the up arrow, and we can just pipe them to unique. And I know that the flag for this is, or the option is -u, which will find any unique line. So it'll get rid of duplicate lines and only give us the one unique. In this case, here is our password for the next level. And I do just want to show you, we can look at the man page for unique. This can do quite a few things. We just did, let's see here. So we can count lines, look at repeated lines. In this case, we did the unique, so we only printed unique lines. But this is a pretty powerful tool that can do a lot of things, and sort can as well. There are quite a few options for different ways to sort things, and just kind of a lot of different ways to look at text and how to output text. A couple of interesting things to look at there. I've used this numeric sort command quite a bit when parsing text files as well. All right, let's move on to our next challenge, which is Bandit 9. Oops, not having issues pasting today. Okay, let's move on to level 9 here. The password is stored in data.txt in one of the few human readable strings preceded by several equal sign characters. Let's take a look at our data.txt file, and we can see that there is quite a mess on the screen here. We see a lot of these strange characters, and this is obviously not an entirely human readable text file. What we can do is use strings to pull human readable strings from this. So let's take a look at the man page to start with. Oops, strings. Let's try strings. Okay. Literally, this just prints these strings of printable characters in files. There's not a lot to it. I rarely run this command with any of these additional options anyway, but they are there in case you need them. But we just want to pull the strings of printable characters. So let's get out of here and let's just run strings against this data file. So we can see several strings that are pulled from it. This one looks like it's a promising lead for a password. We can just kind of scroll up and we see the word password here. And I just wanted to show you how we can maybe narrow this down a little bit more is by using that grep command that we just learned about last time around. Let's pipe this into grep, and let's look for lines that have two equal signs in them. And sure enough, there's our result, and we can see that this is kind of pointing us in the direction of the password being this. All right, let's move on to Bandit 10. And we'll see what the challenge is here. So the data.txt file contains base64 encoded data. So again, let's take a look at our data.txt file. So one easy shortcut to identify base64 encoded data is it may contain equal signs at the end. Those are padding characters. Sometimes when we're converting strings into base64, it will add these characters to the end. Good little hint there. Okay. We're looking at what to do in terms of base64 encoding. Let's Well, let's take a look at our base64. So let's just do man base64. So this is another pretty straightforward Linux command that will encode or decode base64 data. We can see right here, our first option is to decode data. So let's just give that a shot first. So let's do base64-d, and we're going to select data.txt as our file. And sure enough, we get our result. And just like with the previous examples, if you want to just cat this data and pipe that into base64 and decode it that way, that'll get you the same result as well. Alright, this has been part 2 of the Bandit walkthrough. We will continue picking up with level 11 at the next video. Feel free to like and subscribe and leave a comment if you enjoy these videos. Thanks a lot.